Alright, in this video we're going to be talking about one of our 3 transformations that you're responsible for this year, vertical shifts. And what I have circled here in squiggle red is just the generic form of what these look like. And remember, f of x could be any function. We're responsible for linear and exponential this year. But f of x is just a generic form of a function, whatever the function is. So what we're saying here is a vertical shift happens when you add a number to the back of a function, so plus c, or you subtract a number. So c can be any number, and that c is going to end up telling me how much I'm shifting up or down. So if it's plus, hopefully you're thinking up, which is right, and if we're subtracting a number, we're going to be shifting down. So think common sense, don't freak out. So here's just a quick mini lesson on what this is, because it's pretty easy once you see it. So this first one, we're saying who cares what the function is. We're going to call it f of x, but we're going to add 2 to it. So if we're adding 2, that whole function is going to shift up. And I don't care how squiggly or how gross it looks. If it looks like this whole squiggle is going to shift up 2 units on the graph. We're just moving the whole function up. Alright, so this function says we're subtracting 1, so we're going to go down 1. This one says plus 7, so we're going to go up 7. And this one says minus 10, so we're going to go down 10. And again, every point on those graphs, on those functions, moves. So it's not just a point, it's not just a few points, it's every single point on these functions, no matter what they look like, is going to shift in the same direction. Alright, so if we say down 2, everything moves down 2. So here's you a linear example, because that is one of the functions you're responsible for this year in coordinate algebra. So I've got the parent function that we talked about in class in red, y equals x. That's your parent line function, your linear function, before anything has happened to it. So that's the one we're going to compare to. So in blue, I have the equation y equals x plus 4. So we are going to go and plot this, just like we know how to graph lines. Forget the whole transformation idea. That tells me I have a y-intercept of 4, so I'm going to go put a point at 4. And then my slope is 1, so it's up 1 over 1. So I'm going to just draw my line. So there's my line. Well, what we were just talking about was this back number tells me how much up and down I'm going to shift. Well, if you look at your parent, all we've done is added 4 to the function. So if we're adding 4, it should shift up 4. And if you notice, if you want to follow your y-intercept, that's my hint, the y-intercept moved up to 0, 4 when it was at 0, 0. But notice every other point has moved too. This point moved up 4, this point moved up 4. So every point on our graph has moved up 4. Now, with the y equals x minus 6, hopefully you're seeing, well, this is minus 6. We should be shifting down 6. And that's, in fact, what you do, because if you go graph this line like you know how to, just in general, the y-intercept's negative 6. So you're going to put a point, and then the slope is up 1 over 1 still. And I'm just graphing this without straight lines, but bear with me. So everything has now shifted down 6. Every point has gone down 6. So when you're adding a number, you're shifting up. When you're subtracting, you're shifting down. Same thing applies to exponential functions, the other one you're responsible for this year. So the parent that we've been talking about is 2 to the x, and it can be anything. I think later on in the video I've got 5 to the x, 7 to the x, so it's any base to the x power as a parent. But what we're about to do is, on the first one, we're going to go add 4 to that. Well, think about what we just said. That shifts everything up 4. Well, I've drawn in your asymptote here in red. It's hard to see, but it's at your axis. And that's where the parent asymptote is. Well, if everything in the function shifts up, that asymptote should shift up as well, because we're not going to be approaching that same number if we're shifting the whole function up. So on this one, when we're adding 4, the easiest thing, if you look at the hint down bottom here, is to follow your asymptote. So if I'm shifting up 4, the first thing I probably want to shift up is my asymptote. It was at 0 for the parent for all these. Now it's going to be at 4. But then every other point shifts up 4. So my y-intercept for my parent was here at 0, 1. I'm going to shift that up 4, so it's going to be here. This point's going to shift up 4. This other point's going to shift up 4. And I'm going to kind of estimate for the rest, but we know we're going to be approaching our asymptote in this direction. So there's our shift up of 4, 2 to the x plus 4. So everything, including that invisible asymptote boundary line, has been shifted up. Now, this next one says minus 5. So we should be shifting down 5. We'll go ahead and shift your asymptote. Remember, that's the easiest thing to see. So shift down 5 and draw your asymptote. And then shift every other point down 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And again, we just want to get a general idea. If you can get the asymptote, that's the main idea, because you know how to curve it. So everything there has shifted down 5. Alright, so how does this move the asymptote? We just talked about it. If we say we're going to add 2 here, that's going to shift it up to y equals 2. So if you can find your plus or minus out back, that's your asymptote. And down here, this says minus 4. Well, we said that's going to shift it down 4, which is on the graph. That means you're now at y equals negative 4 as your asymptote. And we knew that y equals 0 was the asymptote here because there's no number back here. We have not moved up or down yet. Alright, so the asymptote is the easiest thing to follow. So let's just practice. Where is it at? So pause real quick, see if you can find the asymptote of each of these, and then unpause it and check your answers. Alright, there they are. So y equals negative 1, well there it is. Y equals 4, there it is. Negative 7 and 2. It's that back number, whatever you're adding or subtracting. Alright, so here's your practice. So for each of these, I just want you to determine what is going on. Are we shifting up? Are we shifting down? And on the right hand side for 5 through 8, sorry, if you want to identify where the asymptote is as well, just for extra practice, that may help as well. So pause the video, come back in a minute and check your work. Alright, here we go. So the first one's up 3, and we could see that by this plus 3. Next one's down 4, there's the minus 4. Plus 1, so up 1. Plus 7, so up 7. And same thing over here, minus 2, so that's down 2. That means that's y-intercepts at y equals negative 2, if you wrote that. Plus 1 means up 1, and that y-intercept's now going to be at positive 1. Then you've got plus 4, which means up 4, so that new asymptote's going to be at 4. I think I said y-intercept a minute ago, I'm talking about the asymptote, sorry. And then minus 10, shift down 10, and your asymptote's going to be at negative 10. Alright, so until next time, keep practicing.